There are some visual effects in games that look really good but can take a lot of work and a lot of mathematical rigor to set up. And there are other visual effects in games that look really good but are actually quite easy to set up. And today I'm going to be talking about one of the second kind. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about basic 2D lighting effects in GameMaker. So what we're going to be achieving today is going to be really all that you see on the screen right now. We're not going to be doing anything fancy with physically accurate lighting or normal mapping or M.L or 2D shadow casting or anything crazy like that. We are just going to be creating little circles of light on the screen around objects that you would expect to be a light source in a game, such as this torch, which is standing next to me. So the base project that I'm going to start out with today is going to be more or less the same 2D base project that I've used to demo a number of 2D GameMaker things over the years. I have made a few additions. I have added the torch particles, the fire particles. These are just a particle emitter, and they're not going to do anything fancier than just be there and exist and give a bit of context to what's going to be casting light in the world, because it would be a little bit weird if we just had random circles of light in the world. And I've also gone and made myself a little game controller object. And at the moment, I'm just using it to turn off automatic drawing of the application surface. We are going to manually draw the application surface in the post-draw event. And we're going to use it to draw the particle system in the draw end event after everything else has been drawn, regardless of depth. And I will be using this game controller object more in this demo. I will be using this to manage the lighting effect, because I want that to also happen in, essentially you might consider it a screen space effect. I want it to happen after everything else in the game world has been drawn. Anyway, so for preliminary information that you're going to want before you go and do this, this is a pretty simple effect, but you will want, for lack of better words, a surface level understanding of surfaces in GameMaker. If you've used surfaces in GameMaker before, you probably have enough of a grasp on them that this video shouldn't pose a problem. You will also want some understanding of how blend modes work. If you've used subtractive blending in either GameMaker or other programs such as Photoshop or whatever, then you should be fine. We're not going to be doing anything too insane. And then there's the matter of the application surface. So I'm not going to be doing anything with the application surface other than what's already here, but if you want to know why I turned off automatic drawing of it, and I'm drawing it manually in the post-draw event, well, the application surface has to do with the order of the different draw events in GameMaker, but if you let it draw automatically, GameMaker will try to draw over what I'm going to be doing in this video right now, which for obvious reasons is not really desirable, so I'm going to be drawing it manually here in the post-draw event of the game controller object. I've made videos on all three of those things in the past. If you want to know more, I will have links to them in the description of this video and also in a card that's popping out of the screen. So, let me start at the very beginning, and that is going to be the create event of obj_gameController. And I'm going to create myself a surface. I'm going to call it light surface, and this is going to be equal to surface create. And we're going to want some dimensions to pass into the surface. And you might be tempted to say make the dimensions of the surface because it's going to be filling the entire screen to make this window get width and window get height. But because in this demo game program thing, and because I expect in a lot of people's games, if you're using a view that is following the player around, and the view is not the same size as the game window, then using a window get width and window get height for this is not really going to be how you want to do things. So since I am using views, the view that is following the player around is going to be viewport 0. It's got a width of 320, height of 180, and it tries to keep obj_player approximately in the center. I'm instead going to get the camera, which contains the information associated with that viewport. Var camera equals view get camera, index 0. And I'm going to extract the width and the height information from this camera structure. So var cam width is going to be camera get view width, and var cam height is going to be camera get view height. Like this. And instead of creating the surface 2 dimensions of window get width and window get height, we can create the surface 2 dimensions of cam width and cam height. Okay, so the view surface, the light surface has been created. I'm going to hop on over to the draw end event. So I will talk briefly about what the draw end and post draw events are for. So in the same way that in GameMaker you have the step event, the begin step, and the end step events to allow the developer to ensure that certain things happen before other things. So if you have code that you need to set things up in the step event and you want that to happen before all the other objects run the regular step event, you can use the begin step event for that. You have the same thing for the draw event, so you have the draw begin event and the draw end event. And here I'm just using the draw end event to make sure that the particle system is drawn on top of everything else regardless of depth. And likewise, we also have the pre-draw and post-draw events, which are like super draw begin and draw end. Draw begin, and draw end will all target the same application surface, the same like viewport settings they will execute for each view in the room. Whereas pre-draw and post-draw will happen before and after all that runs. Pre-draw is, I believe, where GameMaker will by default clear the screen between frames. And post-draw would be where the application surface is written into the frame buffer. The frame buffer being the final destination of where things that end up on the player's computer monitor are written to. And as we can see here, I'm doing that manually with the post-draw event. And I will be doing some additional things on top of this later on. So, coming over to the draw end event, I'm going to surface set target. We're going to be targeting our lighting surface. When we're done, we're going to surface reset target. Pop the light surface from the surface stack. And while we're targeting the light surface, we can, for now, simply draw clear C_black. And that is going to fill the entire light surface with 100% opaque black pixels. And because this is just one of those things that everyone should do automatically, and it's not really part of the video, but I want to make sure that everyone has it on their mind at all times. If the light surface does not exist for any reason, because between frames, surfaces can evaporate if the user minimizes the game or something like that, we are going to want to make sure the lighting surface is recreated and make sure it exists before we try targeting it. So that's just a safeguard against GameMaker losing track of surfaces. Coming over to the post-draw event, I'm going to draw surface self.light surface at position 0, 0. So the post-draw event, as I mentioned, runs independently of whatever your views and cameras might be doing, and in the post-draw event, the world origin 0, 0 is always going to be in the upper left of the screen. Whereas in the draw event, draw begin, and draw end, we will still be respecting views in the camera. At least, that assertion is going to get a little bit squibbly when it comes to dealing with surfaces, but for the most part, in the draw begin and draw end event, the viewports in the camera are still made use of when you draw things. Anyway, this is going to draw the light surface in the upper left corner of the screen. And we can see that it's really quite small. It doesn't fill the entire screen. Again, this is only 320 by 180 in dimensions. And if we want this to fill the entire screen, we can say draw surface stretched and set the width to window get width and window get height. Now we are actually going to use window get width and window get height because we want whatever we draw to actually fill the window on the computer screen. And this is going to cause us to see or perhaps not see anything at all because we are now filling the entire screen with a 100% opaque black rectangle that is the light surface. The draw GUI event, by the way, that happens after everything, like all the normal drawing happens. The UI layer happens even after the post-draw event. The UI layer is kind of its own thing entirely. Hence the hearts and anything else that might be showing up on the UI still being there. So, I have in this project two lighting sprites. This first one is a 64 by 64 sort of pixelated circle. We can see that we have white in the middle and then darkening shades of gray, darkening concentric circles radiating away from it. And I also have another circle that is a bit of a smooth light. And this actually is transparent. I would not like this to be transparent, but I forgot to set this up before I sat down to record. I can remedy that by just filling this with black, merging all layers, and then because I don't really need it, I can just delete the parts outside.
Hey.
With the magic wand tool like that. Okay. Forgot to do that before I hit the record button. So, what I want to happen is that for each instance of obj_torch in the game, I would like them to draw the lighting sprite on the light surface. And I'm going to not do anything fancy with blend modes yet. First, I'm just going to draw as you ordinarily would with the with regular blending, and I'm going to say with obj underscore torch, we can draw sprite spr underscore light subimage 0. The position is going to be self.x and self.y. And this is going to have every instance of obj torch in the game drawing the lighting sprite on the surface. And this is where I mentioned that respecting views and viewports and cameras with surfaces is going to get a little bit squibbly, because if I run the game now, we're actually not going to see the lighting sprite drawn at the position on the screen where the torch would be. You would expect the lighting sprite, the torch, to appear around where my mouse cursor is right now. But unfortunately, when you target a surface in GameMaker, it will reset the camera to the world origin. So you will need to take the camera associated with whatever view you are drawing to. And after you set the surface target, you will need to camera apply like this. And this will restore the view and camera settings to whatever they were before the surface reset them. Normally, the fact that when you target a surface, the camera is reset to the world origin to like 0, 0 on the screen, that's a good thing, because a lot of the times when you draw stuff to surfaces, that is what you want. You don't want the surfaces to like exist in world space like that, but for this particular case, we're going to want to actually use whatever camera settings we had before. And now we can see that we have a white circle being drawn on the screen, approximately where that one torch, but that is where the player started out, was located. And if I walk over here, we have another one. If I were to drag a couple more instances of obj underscore torch into the room editor, got a bit of a festival of lights of sorts going on here, then we're going to have more circles being drawn on the screen. Okay. All right. So we still can't see anything. This isn't really very useful. And this is where blend modes come in. So if I were to set the blend mode to GPU set blend mode to BM subtract, and when we're finished, GPU set blend mode BM normal, just to reset it to normal blending. Subtractive blending is going to cause the light sprites to, instead of actually drawing like themselves on the lighting surface, it is going to cause them to, as I've been saying, punch holes in the lighting surface. Right, and now if I were to walk around, you can see that we have these holes being cut out around the torches. All right, and I think I may have made a bit of a dumb mistake in making these lighting sprites opaque, because the color is one thing when you have a black surface, and when you subtract another color from it, you're just going to be ending up with black. But what we're actually wanting to subtract is the alpha, the transparency. And since all of these sprites are 100% transparent at the moment, I'm going to want the transparency to be reduced, so that we only subtract a small amount of transparency from the lighting surface. I'll talk more about the math at the end of the video. Let me just restore that to what it was before. All right, I was not thinking earlier in the video when I did that. Anyway, let me run the game again, and we will now have the lighting circles, but instead of just being completely like punched holes, we're gonna have a bit of a ring around the lights. And of course, we can, if we want to make these bigger, if we want to make these holes bigger, we can say something like var scale equals 2, and then draw a sprite extended with the scale factor 0 rotational, though that's kind of besides the point because we're drawing circles. Color can be C underscore white, alpha can be 1. And now we have bigger circles here. That's pretty cool. So we now have a basic version of 2D lighting up and running. I do want to do a little bit more with it, however. So you may be wondering what happens when these circles of light intersect each other, and I can also say, if I wanted to demonstrate that, I can have a light that follows the player around or something like that. and I can show one of these circles of light moving around, and for the most part, it works pretty well. At the very edge where the like rings of light overlap, because this is pixelated, you do have a bit of an effect where the light like darkens and then lightens and then darkens and then lightens again, which is a bit odd. And you can either tolerate that, you can deal with that by not having any transparency around the edge of the circle so that that doesn't ever become a problem. You could probably use a blur shader on the light surface to minimize the impact, although I'm not going to be doing that in this video, I don't think. But you can see now what happens when the light follows the player around, and when where was I going with this? You can use this to give the player a flashlight that will uncover whatever's in the darkness or whatever. If you wanted to use, instead of that very pixelated light sprite, if you wanted to use the other light sprite, I'm going to var sprite equals pure light smooth. I will use a variable to reference the sprite so that I can switch between them quickly just by changing that one variable. This is going to give us a smooth light ring, and we also have a I don't know. I think the problem of the transparent like light pixels around the edge is lessened when you have a smoother light sprite like this. That is 100% a matter of opinion, and you can decide that you like smooth lighting like this even in a pixel art game better, or you can decide that it's stupid and you don't want to do it. Some other things you might want to do is you might not actually want to draw the light surface at 100% opacity, because you might not actually want the unlit regions of the game world to be in complete darkness, unless you're making like a hidden information game where the player is supposed to maybe really not be sure what's in the dark regions. You probably want at least some light to be, for lack of better terms, the ambient light color, and we can do that with just by messing with the alpha when you draw the surface. I can use draw set alpha for surfaces, right? Set it to 50% when we draw the light surface like this. There's also a draw surface extended version of the surface drawing function, which will also achieve the same thing. And you can see now that the regions outside the light are a little bit darker, but they're not completely dark. And I can, maybe I want it to be a little darker than that. We can set it to 75% or something, 0.75. And now I think the unlit regions of the room are sufficiently dark, but not like completely an all-consuming shadow or anything like that. Let's go back to the pixel light sprite for now. Oh, I suppose you could also draw clear. I keep wanting to call it draw clear extended, draw clear alpha, to clear the screen to, instead of 100% black, you could clear it to 75% black or so, and that should, in this case, do the same thing. Although, yeah, we still have the semi-darkness outside the rings of light. Although, when it comes to surfaces in alpha, you can sometimes end up with problems that you didn't expect to end up with due to the way the blending works. And it might be more trouble than it's worth to do that, and it might be preferable to just set the surface alpha to 75% like this, especially if you try to do things with, like, other colors on the light surface. Next, you may want, and I had this in the little demo at the beginning of the video, but you might want the light sprites to, instead of being a fixed size all the time, you might want them to wobble a little bit, the way that you might expect a candle flame to flicker, and you can do that with either adding a random number to the scale that you draw them at. So, for example, a random number between like 25% plus or minus 25%, and this will cause them to flicker. I'm not sure if this is actually going to look good. This might trigger, yeah, I'm not even going to show that on the video. That might trigger a bit of a photosensitive epilepsy in people who have trouble with that kind of thing, so I would recommend not doing that. You could also, and this will be a little bit more tame, use a sine wave or cosine wave to have a smoother oscillation. So if I were to say, and I forget what parameters that I settled on before when I was planning this out, because I didn't write them down, but if I were to say something like 0.25 times sine of the current time divided by 1,000, so this is going to, current time is the number of milliseconds since the game started, If you divide that by 1,000, you'll get the number of seconds since the game started, and the sine wave will oscillate between 0 and 1 in a smooth wave in a period of 6.28. So we will go from a smaller lighting sprite to a bigger one to a smaller one in a period of 6 seconds. If you want to speed that up a little bit, we could have we could increase the period a little bit. That's still a little bit slow. Also, I think it's a bit of a big oscillation, so let's shrink that a little bit. All right, that's not bad. We now have the circles of light flickering a little bit, or pulsing, or whatever verb you want to use to ascribe to this effect. All right, one last thing that I want to do before ending this off, and I was going back and forth on whether I wanted to include this or not, but I couldn't resist. So let's say that you don't want the parts of the game world that are out of range of the lights to be just black, or transparent black, or whatever. Maybe you want, for example, something more like a bluish color tone. We could clear the screen to a color that is not black. We could clear the screen to something like 0 red, 0 green, and like 2 0 on the blue, which is going to be that 12% blue. And we could run the game like this, and this is going to cause the parts of the screen that are out of range of a light to be a dark blue, like a midnight blue, instead of black. And you might prefer this. Oftentimes in games and movies and other visual media, you would indicate nighttime with something like a midnight blue color like this. And again, that can be quite useful. If you wanted to maybe, let's go with like a quarter red. What is that? How many zeros is that? 0, 0, 0, 0. I need one more 0. This should give us a bit of a like hellish inferno. Like if you're in a volcano or in the underworld or something like that, you can play with the colors like this. Be careful with alpha. Be careful with colors and surfaces in alpha, because if you do weird things with those, alpha and surfaces could come together in unexpected ways. But if all you're doing is drawing lighting sparks like this, you should be fine and it shouldn't be a problem. And seeing as that's the last thing I wanted to do in this video, I suppose I did say that I would talk about exactly what's happening with the transparency when you punch holes with the math and everything in the surface. So since we're using subtractive blending, that is going to cause the color that we're drawing, the color of each pixel that we're drawing, to be subtracted from the whatever color is already on the light surface. And that does include alpha, so if you have just black, which is just 0 across the board, is at 100% transparency, and if you subtract white from it, you're going to still end up with black, because 0 minus a number is going to be something below 0, which is just going to be black. And that's also going to count for the transparency, so if you have 100% transparency and you subtract 100% transparency, you're going to end up with 0 transparency. If you have 100% transparency and you subtract 50% transparency, like the edges of these light sprites, then you're going to end up with 50% transparency, which is what gives the lighting sprites a bit of a feathered edge look like this. And since that's all we're doing here, that's really all there is to it. But if you were to draw, if you were to clear the surface to a navy blue like this, and if you were to draw a lighting sprite of a different color, then you would suddenly be subtracting values, like color values, red, green, blue color values from the lighting surface that weren't just a number from 0. And you might end up with colors that you didn't expect.
Hey.
But that's really all that's going on here. So I'm going to end things off. If you want the code for this, look for the GitHub repository in the video description. I'm going to end the video on the screen because I think it's kind of pretty. I have a Patreon, so if you want to contribute towards the channel, look for the links to that in all the usual places. I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game, which is currently a bullet hell. I do like to talk about the weirder things you can do in GameMaker, so if anything like 3D stuff or shader stuff appeals to you, feel free to subscribe. I wanted to make this video for a long time, by the way. Like, really ever since I started making GameMaker videos again. And when I finally did sat down to record it, I had to go through like 4 versions of it before I came up with a version that I was happy with. Anyway, I hope you all found this useful, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Gunnar Clovis, KeyXE, Sindra Larson, Squarecrow, and Zenjamin for supporting these videos. If you want to support this channel yourself, head on over to the Patreon page down in the video description to join the fun.